So we'll get into our last bit. We're almost done. All right. We're going to have our HR diagrams. And so you're going to see plots like this a lot for the rest of the semester. So what are HR diagrams? They're named after the scientists Hertzberg and Russell. And the idea is simple. If we plot the spectral class, or another way to put it, the surface temperature, versus the luminosity of the star, where do the stars fall? Where do the stars fall in that pattern? And we're going to notice characteristics. We're going to notice what we call things like the main sequence stars, giants, supergiants, dwarfs. We're looking at where stars fall on this Hertzberg-Russell, or HR diagram. You're going to see a lot of different ways to plot the X and Y axis. On the X-axis, we can put spectral class, we can put temperature, we can put peak wavelengths. There's a lot of different ways, but they all represent the same thing. Effectively, the temperature, where this is the hottest and this is the coolest, versus the energy output. So, for starters, we said about 90% of stars follow that L is into the fourth pattern, right? That's what we mean by the main sequence. And to put in perspective, why discuss... Here's the main sequence, all right? There's your main sequence stars. Why do we care about those? For perspective, we can talk about an analogy with humans, all right? Take a sample. Let's say I sampled everyone in this lecture right now. You told me your weight and your height. Most of us are going to fall on this main sequence of humans. We're all going to fall into this main sequence where the taller we are, the bigger we tend to weigh, with there being outliers in both directions. So we can say most follow the main sequence. The same thing applies to stars. Now the emphasis here, an important thing that we're going to build up here, is that the main sequence stars, where a star falls on the HR diagram, it's going to tell us about that star's life. So, look at our main sequence, O, B, F, G, K, M's, right? These are the main sequence stars. They're going to start from high luminosity, high temperature. They're going to go down to low luminosity, low temperature. Yes, our sun is on the main sequence. And here's the emphasis. If I know the star's spectral type, I know which one of the categories the star falls into, and I know where it falls in the HR diagram, this is actually a way for me to calculate its distance. The actual technique is called spectroscopic parallax, and we will delve into this detail later on, around section 19. But we will talk about how I can use the spectral type and its position on an HR diagram to get its distance. And I've said this before, and this is going to really start applying a lot now. Knowing the mass of a star helps us predict where in the HR diagram it falls and what its life cycle is going to be. So, not all stars are going to be on the main sequence. We can talk about the giants, how a star can go from on the main sequence to leaving the main sequence. And you're going to get some weird examples here. Some stars are going to be very cool, right? Remember, this end of the spectrum is the coolest stars, but the higher up we go, the more luminous we get. So we're going to find stars that are not that hot, but because of their volume, how big they are, they're going to be very luminous. So the star will be cool, but it'll be brighter compared to other stars just because of how giant it is. And the opposite exists. We're going to have very, very hot stars that are not very luminous because these stars are tiny, compact. So there's definitely a relationship between how luminous a star is and its size. All right. So, summary of what we've talked about so far. We know that there's a relationship between luminosity, brightness, and magnitude. We're going to start talking about stars of where they fall on the stellar spectrum. Remember, O, B, A, flying, Gus, kiss me. Right? And from these things, we've talked about how to measure all sorts of a range of stellar properties. And with those, we're going to start plotting stars on these HR diagrams, these Hertzsprung-Russell diagrams, and start discussing their stellar evolution. All right. So, hope everyone enjoyed these lectures, and we'll see you next time.